There is some books. I really recommend to read. I don't know just which one you need it. For when you have the C++ language, it was the first book released, like design patterns. Its original authors, like it's called, or also known as GOF design patterns, or Gang of Four, and it released in 1994 year. And this book is really old, as you see, but those design patterns, it's only ideas, and you don't need to update, because it, like in math, when you have some formula, and really doesn't matter which year book you're reading, you will get the same information. And basically, in C++ language, syntax written the original book, and there is some object-oriented software creation using design patterns. And of course, there is some other languages translated to Java language, and of course, it's really more interesting and more fun book when you reading headfirst any type of headfirst books. You will find really useful examples and practical, and not so much theory added to those books. It's really too easy to understand and catch up. And yeah, but when you're reading original books, you will find maybe a lot of, I don't know, theory inside those books. But yeah, doesn't matter which book you're picking. Design patterns basically for programmers. There is a top first requirement when you're working in any company, because design patterns, it's idea how to better manage your object creation. For example, there is three types of design patterns, like object creation, object behavioral design patterns, and object structural design patterns. And basically today we look to the structural design pattern, composite design pattern. And later maybe I make some other examples for object creation and for object behavioral design patterns. But for a moment, we need look to our task 4, and in task 4 you will find design pattern composite, structural design pattern, and you need to implement software which is simulates any topic, doesn't matter which type of topic. I'm here added some example, and today I will implement this example to show you the result of composite and some advantages why it's good. And yeah, it's really flexible design pattern when you need to have some structure. And basically, if you're reading and you need to understand what this design pattern is, design pattern based on the following principles of object-oriented design. For design patterns, basically you need to have object-oriented programming language. And you give program to an interface, not an implementation. That means you give a basic functionality, a basic idea, how to manage or how to make your program flexible, more flexible, for example. I don't know how to say that different between implementation. You don't need to implement to work with design pattern. You just not explode your program, or you not follow any style of coding. You're just making some design pattern which just helps you work with your program, and when you're making some changes, you not need to change that design pattern basically. And sometimes some design patterns, of course, have some templates, of course. For example, model view controller. If you have some UI programs, like you creating some views, like a web browser view, and you're creating some models like objects, and you creating some controllers, which is controls that code between and connect to those views, for example. And favor object composition over inheritance. Basically, all design patterns implementation or templates is to have some composition, basically create separate objects instead of inheritance, because when you have some hierarchy, like, I don't know, just number Java class, just when you have some hierarchy of classes like this, doesn't matter which type of classes, you have object and it depends on number depends on byte, float, and etc. And when you're using design patterns, it recommends do not use those type of hierarchies or inheritance when you're working with design patterns. Of course, you should use some inheritance in some cases, but it recommends in some way not use inheritance. And for that reason, it's more flexible code because you're not dependent on any hierarchy like here. And when you're making some changes in the middle of hierarchy, like here, or doesn't matter here, or any layer, it's easier to if you have really huge stuff like this, it's really hard if you need to remove something or doing something like when you're changing in your tree something. And yeah, the basic idea is to help to solve the problems, some problems using design patterns. And one of that is composite, is a structural design pattern. And for your task, you need to implement composite design pattern. And how to implement this when you're working with when you're working with C++, for example. We have the empty project, and in our project we need first to create. I need maybe to split screens now and make like this. Okay, we just smaller sizes. And now our goal is to implement this design pattern. First, you need to understand how it works. Basically, the yellow is the object which you're creating, like the root or parent class is the computer, yellow color. Composite objects basically is all green objects. All green objects in programming language is arrays or lists of objects. Like computer have inside a cabinet, like cabinet have inside other components like HDD and, for example, motherboard, and motherboard have some RAM and etc. And basically the red color is the final component or object, which is leaf. Like, because we have the tree structure, and if you would like to implement the tree structure stuff, you should implement like leaves for tree, and instead of nodes, basically here is a nodes, we creating composite objects. Those naming needed to understand first design pattern, how it works, and after this you're able to use some, doesn't matter which type of name here, like class, object, node or composite, or it doesn't matter which type of object. Basically, green color is the list of some elements. Inside that list, you're able to add it some component, like single component as a leaf HDD, and you're able to add it another list of component inside that list. Like you have the list, and inside that list you have another list, and in that list you have that two elements added. And you're able to grow your tree and have a really complex structure. But why is great? Because you're able to pick any node and get this information from that node. For example, you have a lot of structure and you need only peripherals devices. And for that reason, you just picking peripherals node, and you get all the list data, all leaves when you need it. And if this object have some price, for example, details or any properties, you're able to get those properties also and work like as a normal list. Basically, you're able to create some categories, for example, and subcategories and etc. Like if you have some web, for example. And yeah, how to implement this? We need to implement first some type of object, and this type name when you creating the object, when you're creating composite design pattern, we can call it component, because the component basically is HDD is component, and cabinet is also component, or motherboard also component. Instead of abstract name like object, we creating component, for example. New C++ class. Basically, we don't need to implement this class, and instead of this, we're able to create only header file. And that's it, what we needed here. We're creating only each file to implement only that structure of component. We have computer shop composite component class, and if you remember, here is defined def guard, which helps not include twice in your code. It's like some guard from that happening. And we, as you see, have only H file here. And inside here, we need to implement a class, which is component. You're able to pick different name, but I suggest to use the same name of that class. And now, if you would like to implement functionality, we first need to look to that, for example, topic, make a filter, price for motherboard, price for peripherals, and each component total, for example. Yeah, we need some price, and we need what else we need? Price and some details, for example, for components. And how to implement this? We need some functions. As I mentioned before, we need to implement abstract functions. And in C++ language, abstract function is virtual function. And when you're writing the virtual, of course, we need as a public function, because we need to use it somewhere. Virtual void, for example, show details. Show details, we just showing some details for component. And also we need virtual double get price. And basically you're able to create more virtual functions if you need more functionality. I'm just leaving here a 0. That means you're creating abstract function which is not implemented yet. We're just creating abstract component. And when you have inheritance, you're able to implement those, show details, and get price in child classes. And at the moment, we have two types of child classes, like composite and leaves. And first, maybe we implement composite class. Composite. Composite class should inherit, because we need to say that our composite is component. Our leaf is component. For that, when you're using inheritance, you say that here is that like that type. And here we say virtual public, because we implementing our abstract component, which is abstract class. Component. And we need to include this class to use it, our virtual public component, because in this class we have not implemented those two functions. And now in our composite.h file we need to create a structure. First we adding public fields, and then we're adding private fields. In private fields you need to add it some stuff. And what we need, I need to look somewhere. We need some price, for example, and here there is no. For composite, we need to have the list. Green color means here is a composite object list. And basically we creating, or we need to include here a vector, and we need to add it here as a vector, std vector. And in vector we holding the component reference. Why we need that reference here? Because we not initializing those components, because we not yet initialize those components. And for that reason, in C++ language, in different language you don't need it to use pointers, because you don't need to manage memory, and if you do not face some problems with memory, you need to create a vector, or here is a list of components made from pointers, references. We holding references instead of object instances inside a vector, because you're not able to create a component type instance. You're able to create a composite, for example, or leaf, which is implement those functions. But for a moment, we can only hold the references inside for that type. And our reference will be later the composite or leaf here. Yeah, later we're creating that.
Sorry, but we need to write like std vector. Yeah.
Yeah.
Using namespace std and that's all.
Yeah, you're able to use it namespace, of course, if you need it.
Like it doesn't matter, yeah.
Yeah, it's really doesn't matter at the moment, but it's not a great practice, and it's bad practice when you're using the namespace, and because sometimes you implement your own libraries and you don't know which library you're using, default one or your own library. For that reason, using namespace std, if you have the huge projects, basically you get or face some problems. But at the moment we can use it because we have small project here. It's not a big deal here if you're using namestd. Yeah. And here we're creating our components list. We're just writing, I don't know, just components, for example. Yeah, we have components. And of course, as all composite, we need a name. For example, cabinet, motherboard, peripherals here. We're just creating a string name, and we need to import maybe just a lot of string. As you see, library is different, and basically if using std, you know that using string from std but not from somewhere in that case also. But here it's only that C++ language world. When you have different languages, it's really easier because it's more, I don't know, cleaner because it's a higher level, or more modern languages already cleaned that mess. But when you have the C++, you're able to control the memory. For that reason, you need a lot of stuff to do. Write some syntax, exotic expressions. And yeah, we have two type, like name and component. In public field, as a public field, we able to create some stuff here. First, we should implement our virtual functions. And those virtual functions was show details and get price. Oh, sorry. Yeah. Void show details. Basically, here we implementing our function, and for that reason we need to mark as override, because we overriding that function from the parent class component. And we also need to mark get price also. Implement here as overriding here function. Not void, sorry, double. Basically, we overriding that virtual function from abstract or virtual class. And also we need to implement constructor to initialize the name for cabinet, peripheral, motherboard, this matter. For composite object, we need to initialize name. When we creating, we need the name. We creating constructor. I recommend to use generator, alt insert, and constructor. And we picking the name. Okay. And when you generating here, you're generating basic constructor, composite, as you see here. Yeah, composite constructor passed only single parameter name. And now we need to implement our two functions. First function is from composite show details. Another function is get price. As you see, it's autocomplete. It's really great, and you don't need to make any written of void, double, or doesn't matter. We basically, as you see, that arrow means you implementing overriding some function which is already added in composite and component. It's like connected to main class like component, because component is composite object, and later we create a component that also is the leaf or child object also. We have list, and inside the list we have the same type components. And here we have two different functions, show details and get price. And what you need to display here, you really picking your, it depends on your implementation. And maybe I making a helper class also later for colors, but now we're not creating, we just printing out some information. Like cout, and as you see here, we doesn't have the std, and if you needed to use here std also, we go to composite h, and we adding iostream, because we need to input output operations. For cout we needed this. And now we're moving to the Composite C++, and cout is now working because we added that IO stream working with that library cout, for example. And we couting some info. I'm just adding, as always, some fancier stuff to see the difference. To make it more fancier output, we need some stuff here. I'm just adding here as composite object output. And what we need to display as details. We need a name, for example. Name, because we already have the name implemented in our class. And what else we have here? Get price. We don't need the price, maybe, because we have the cabinet, and at the moment we don't need the price. Price, we have get price function. Name, and maybe that's it enough. For example, we have the name of our composite object, and now we need to print that object and show some details. Oh, sorry, for component, we using as a pointer because we have the pointer list, and we picking components class list, sorry, not just shortcut comp. We just iterating through that whole collection, because in our composite, in our cabinet, for example, we holding a lot of other objects or lists, or doesn't matter, sublists or like this. And what we need to do here, we need to call it our show details function. What's happening here, as you see, we have show details function, and we have component show details. That means we have some recursive callings, or here it's not really recursive, but it's really similar, because we calling not composite show details, but we calling each component show details function, because our component our component basically is a cabinet, and HDD is also component. Basically, you get all information from cabinet, and inside the cabinet is one component. And if you see motherboard, you also get from the motherboard all leaves or those components information. Basically, as you see here, you get the whole tree information if you're calling the parent class computer. If you're calling peripherals, you get that information. If you're calling left subtree, you get left subtree information. Basically enough to have the single for loop to iterate through the whole tree. And now, what else we able to do here? We need to implement our get price function. And get price, because we have the list, or all tree or subtree, doesn't matter, we have that group of components. For the group of components, we're able to calculate total price, for example. In your example, we need to calculate total price. And for total price, we also use the same computer component, sorry, component. Oh, Sorry, clean it here. Yeah, we're reading the same components references because component is abstract object. And later we implement those objects, and when we implement it, we're getting the reference to that object instead of creating new instances in loop. Because we're not able to create the instance of abstract objects or classes. And composite get price. How to calculate total? It's really easy. We just total plus equals comp dot get price. And of course, when you calculate that function, we need to return total. Here we implemented our functionality for total price of composite objects. Basically, of all selected 3 sub 3, we get that total price here. And we implemented our composite object, that green color here. And next step is to implement our leaf or red color object. We're creating class leaf. Leaf should inherit from virtual public component. Importing the component, and we including IStream, we including string, we using namespace std if you need an easier approach. And what else we needed? Because we doesn't have any list here, we need private fields and we need public fields. Yeah, basically you need to say the public, private, protected. In that way, you're able to make it here. And now to implement our component leaf. Basically, leaf is also virtual public component, and leaf have name and price. We have string name and we have double price because each component has a price. Name price, and as a public we need to create our leaf or object HDD, for example. And our HDD will be constructor of name and price because our leaf or computer part should have name and price. And here you got generated constructor. When you're creating object, you passing name and price. Basically, it's default generated stuff. You don't need to make any changes inside this leaf. And what else we needed here? We need to implement our component abstract functions. And those functions basically the same. Void show details, override, because we overriding or implementing from component this function, and we need double get price. Override. Yeah. We implementing the same functions which is already implemented in composite design pattern. But composite design pattern has own show details and get price, and each object or single object has also own prices and own get price function and own show details function, because you're displaying the single element. In composite object you has the list of elements. Basically when you're calling that function from this child element. And how to implement? It's really easy. We hitting Alt Enter and void leaf show details, and we need also leaf implement get price. Oh, not lead. Get price. Get price, we return price. It's really straightforward to getter. And in show details, we need to display our information to the console, like cout price or name, sorry. Name, just name. We don't need to print as a string. Why it's black, I don't know. We just outing name, and we also outing our price, for example. Name is that one, or we just, okay, we leaving price, and we adding, for example, end line. Price. Dot. Basically, here we implemented our leaf like object. If we creating the HDD and we calling show details, we get HDD price and price. And here we basically implemented our leaf composite, as you see, composite object leaf, and that's it. We already implemented our composite design pattern. Like, we have composite object, we have component, we just have few virtual functions. You're able to add more functionality if you need it, but I'm just showing that example which is in your tasks. And we need to test it our program now. We're using namespace std as you want. Easier approach to use cout. And now we need to create our test object. Basically, we need to create computer. Computer is composite object. Composite pointer of computer. And we need to create like, are you able to create as a component? Component, for example. Import class. We importing component. We also need to import composite. We also need to import leaf. I show a few different approach how to create the object. Here, when we're using the pointers, we allocating the memory, like dynamic memory, for each object at the moment. A new keyword is allocating the memory. New composite object. And we passing our computer, or just making an uppercase computer. And local never used, why it's gray. And we creating other components, which is peripheral and motherboard. And we're just writing here as peripherals, and here we write motherboard. Yeah, we created 3 composite objects. component on the left side because it's not able to have instances, but our composite class implements those two functions. That means here is an object which is implementing that functionality for a component. For that reason, able to use as a parent class on the left side as component here. Instead of writing composite, you're able to make component equals new composite. Basically, you're creating instances and allocating memory, and just that's it. And now we need to add more stuff here. Be able to create also components. And first component is HDD. Yeah. And here is not composite, here is leaf. And if it leaf, we have, for example, HDD, which is cost 25, for example. Double Seagate hybrid. We have some data. Yeah, Seagate hybrid to 5 gigabytes, terabytes maybe. Sorry. Yeah, price is 140. And now we also creating more components. And we have a lot of those components. HDD, RAM, CPU, mouse, keyboard, monitor, speaker. Just more components, yeah. And yeah, we need to make some prices, or just I'm just opening here. And we need to change some prices like 122. CPU is 455. Mouse it's like 80 euros. 15. Keyboard it's 20. Monitor it's like 595. And we have the speakers, which is cost 12 or maybe 120 more. Yeah, and we created, as you see here, composite and leaves. Composite basically is a list, or leaves basically single objects, like leaves objects, which is have only a description with name and price. Here it's only the name. And now we need to make some crucial. CPU, for example, Intel X9. Just some names, yeah. Mouse, Razer, Naga. Just some keyboard, Logitech X350, doesn't matter. Just monitor, it's like Dell XP TFE. Some names, yeah, custom names. Speaker like Samsung, Video. Spatial. So we have some different names, and we have computer, and we have a lot of objects created already. And in our case, we need to attach those components to each place. For example, to cabinet, we adding only HDD and CD-ROM or some other stuff. And how to make this? If you not implemented picking from the console any input, we just creating the test. We attaching like this. To computer, we able to add it. We doesn't have any function. Yeah, we need to create some function for add components or attach. And now we should go to the composite implementation and create function void add component. Add component, and we passing component. Component, which is component. Yeah. We created another function which is adding component to our list of components. We just creating generate and creating how to add it. How to add it is really easy, just components dot and place back components. That's it. Or pushback. Add component. Basically now I see that when using pushback, you're basically using and place back also. In implementation, when you go into implementation. Add component should add component to your list. And now, when we move into this implementation, we able to computer. Oh, computer, we have some problems. Composite. Maybe it's not saved already. Computer get price. Strange. It's probably here, but we have component. Composite add component. Okay. Here will be the problem because here the parent class, which doesn't have that functionality. Yeah. If we make auto, we need to check it here. Computer dot, yeah, that's a reason. And also, yeah, it recommends in C++ 11 standard use auto to make it type. And basically instead component here we should use composite if you would like to add it components to composite stuff. Because component doesn't have any list, and for that reason you need to write composite to use composite functions implemented in composite class. Because component is abstract class which doesn't have any functions implemented. Basically, you're not able to use any function from here, and if you're not implementing here any lists, basically we're not able to make it like this. To make it component, we should use composite each time to write here composite. Instead of this, of course, it suggests to use auto keyword. You don't need to think that you're just creating here auto split, y split. Okay, auto, making auto stuff. And also here. Yeah, and on the left side, basically you show which type of object you're creating. Auto type detects that you're creating leaves, and here you're creating composite objects. And basically it suggests to use auto in that case. And when you adding to computer our composite object, like HDD, you're just writing like this. Computer add component, and later you computer add component, which is peripherals, computer add component, motherboard. Yeah, and now we already added computer HDD, peripherals, and motherboard. Before this, of course, we need to attach some parts to each separate stuff. Like to peripherals, we need to add component, mouse, peripherals, add component is keyboard, peripherals, add component is monitor, peripherals, add component, speaker. We attaching all stuff to peripherals and to motherboard, or just able to add it here. To motherboard, you're able to add components like RAM, motherboard, add component, CPU. That's it. Basically, we adding to the sublists or to lists or other lists. And here, as you see, motherboard, peripherals, computer. And what's happening here? We just making that structure which is implemented like this. And you're able to use the functionality for your, for example, input from console to create motherboard, to attach some parts to motherboard, after this picking peripherals, to attach some stuff to peripherals, and etc. I'm basically able to create the filters or some stuff like this. If you need to print the price of a computer, you just calling computer dot show details. When you're calling computer show details, you're printing out all the stuff to the console, and you see here we have computer, we have Seagate hybrid 2B HDD, you have peripherals, which is Razer Naga, Logitech, Dell, and Samsung, like 4 parts. And you have that motherboard, which is have integrated, really not integrated, but added some Crucial and Xeon, like CPU. And for example, I need to display only peripherals. I'm just calling peripherals, show details. And as you see here, we got the output, peripherals, Razer Naga, Logitech, Dell, and Samsung, etc. Prices and details for your all peripherals stuff. Basically able to group your any software able to make it like this, and able to make that filters like only calling the function show details and reference of object here, peripherals, for example. And what else we're able to do here? We're able to calculate the sum of total price for those products, for example. How to calculate total? You're just able to see out peripherals dot get price. because in composite pattern, as you see here, we implemented our functionality how to get price. We just reading whole list and we summing up our get price from each component, each leaf. Leaves our cases is now Razer, Naga, Logitech, Dell, XPS, etc. And when you're calling get price, it counts total price. You're just able to write total price. Total price, we writing euro and we adding end line. And now we have the function which is prints also total price. We have peripherals, we have Razer, Naga, and etc. And we got total price for those components here. And yeah, if you changing some here, you're able to get any information like, for example, how much cost our computer. You just changing here to computer. And you see all those parts added to our computer and you see the total price here. Yeah. And another stuff, I would like to mark some colors and show how to make that own color class to make it more fancier in console, like to make some colors here. Basically to separate like composite objects, make some color, and text, basic text. And how to make it in C++ console color, you're able to create new class, color. And in color class, you need to create a public method. And for color class, we need to create our function, static function, because we don't need to create instances of color class. We just need to use that function from color class. Void, for example, set color, set console color, and we passing some color code. And how to implement this? We just implementing in C++ class here. In our case, we need to include, I'm including here windows.h class. In windows.h you will find some handle object which helps later to have some colors. Get std handle and std output, basically here it's for example. And you're able to use the function set console text attribute. You're passing that handle and you're passing our value. Here it's basically we creating the static function which sets the console color. The moment just helper function, and if you need it in some other programs to display some colors, you're able to use it this example for your implementation. And now I'm going to Composite C++ function, and instead of black stuff, I make that composite objects which is green, try to make it some green color. I know that 2 is lime color, I don't know which type of different color is, but you're able to set console color like this. We calling our color class. Of course, we need to include color H. And when you're calling color, you're able to call set console color function and pass any value. From 1 to 10 or more, be able to check it. And when you adding color 2, you're getting all green color. If you need to edit more component colors down below here, you're able to make it here a different value. For example, 44. We try to just see how it's like with some effects. 22. Like this. Yeah, but here it's different color, like 8 maybe. Yeah. 8 is black. Okay. And now as you see, green color is composite objects, and black color, or it's like, yeah, gray color, it's your leaves. And those leaves, as you see here, all leaves, or here it's those composite objects. If you printing out computer now cabinet to see more, it's not cabinet, computer peripherals motherboard, yeah. We need to create cabinet, for example, also. Okay, we creating cabinet, and we writing cabinet, and we added to computer our HDD. No, we need to add to cabinet. Computer, yeah, the last one, cabinet, add component, we adding HDD, and to cabinet we adding motherboard. And instead of computer add motherboard, we're adding cabinet, peripherals and cabinet. And here we just printing cabinet. Our case. And you see our cabinet has HDD Seagate Hybrid 2 and 5 terabytes, and motherboard has those stuff added to cabinet. Basically, we have those two green leaves here. Those nodes which is have the leaves like red color or black color here. Motherboard has two parts, and of course we printing the total price of computer, but we need total price, for example, for cabinet. And total price for cabinet is 646 euro. We just sum HDD plus motherboard stuff here and get the total price. Yeah. And here, that's it, how to implement this functionality using composite design pattern. Do you have any questions?
So our main idea is to create something like that, yes?
Yes.
Something similar, something.
Basically the same, but because the design patterns basically is templates, or no, similar to templates. Like you have some template and you're using those that structure or structural pattern to implement the same but different topic. And of course, I would like to see some interactive console app, which just lets you enter some information from console, for example. For example, you're creating some menu, because here I'm just testing our object creation inside that main, and that's it. In your case, you should create some switch, for example, and input 0, while input not equals 0. Of course, here is 1 maybe. Okay, here you should, of course, enter some information like input, case 1, case 2, default, break, case 3, break, break, break. And yeah, basically here you're just printing some output for menu. Cout one is sorry, end line. Okay, cout 2. um, 0, for example, exit. Yeah. 1. Yeah, here you're able to pick any functions to create. I don't know how should you work your system. Maybe, for example, create computer from scratch. Generate computer, or just suggest computer. Suggest computer, and here I don't know, find, or I don't know, just okay, also create by price, or some other function. I know, just some other function, for example. Create from scratch, you're able to picking that function and you creating from scratch. Suggest computer, you're getting some computers already created, or just generate randomly to create some computer and suggest, for example. Really doesn't matter how you implement this. And in case first, for example, we need to create some function. Maybe we create a function inside here. Okay. I'm not creating any class, I'm creating a function here. Void create from scratch. You're calling some function. Oh, we need to move. Okay, I'm adding that code here, and we need to move inside outside. Maybe here it's wrong, or no, it's okay. Maybe here. Yeah, it's infinity loop. That's why it shows yellow color. And yeah, first, for example, create from we need to add here. create from scratch. Second function will be suggest computer. Void suggest computer. And you just calling suggest computer. And break suggest computer. Okay, we need to implement. Basically, here is empty implementation. Why it's case to it endless loop. Maybe we miss something here. Case 1, case 2, default break, default break. No option or bad option. Oh, we need sin. Forget to input something. Sin. Sorry, wrong side. Input. Yeah, we need to input something. We inputting something and we creating from scratch or suggesting computer. And when you creating from scratch, you should create from scratch. And basic idea is to input from the console. And I don't know how it's better to create from scratch. Here you show that pick case. Yeah. Oh, we doesn't have any case. Just pick peripherals, for example. And you should to enter that peripherals from, for example, list, or I'm not sure now because you're able to implement different way, like to enter your name or to make it as another search or just displaying some from the list. Like creating, no, just vector also is from string. Ferals, because you should have some database and you able maybe have some peripherals added here, like which is peripherals. I'm not sure now of this one. Peripherals. Oh, it's some wrong. Oh, sorry, wrong here. Perf, because we have the same name. Logitech. We have few of that, yeah. And we should display, for example, for loop item from perf, and we should see out I is our name, and we need the index. Yeah, basically better to use index at loop. Or because we need the index of our perf dot size. And here we just printing our index, and here we printing our name, like perf I and line. And of course, there is no option like to validate this stuff at the moment, but we just saying something like int input, or just int choice, choice is 0, but we just reading choice. Yeah. Okay, we just line up. Vector perf, we just reading some list, we displaying the peripherals, we just entering choice, and now we should create our peripheral and add to peripherals object. Basically, when we have computer, we have the rules that all components should add it when we creating from scratch. Like we have the computer, peripherals, cabinet, and motherboard, and those other components it's adding during that creating from scratch process, for example. And in our case, we adding peripherals, add component, and we adding new component from here, from pick Razer Naga or Logitech. And our new component basically is auto component equals, sorry, we need a pointer, and we adding new leaf, and at the moment we doesn't have the price, so able to create name and price, and able to make not vector but map, because map is really similar to this. We have name and value, for example, but if we have like this, able to create like this. Name is our perf dot at index, and index is choice. I'm just using the function perf at choice, or able to use as an array like that way, perf dot choice. If easier for you, using perf choice like this. And here is the value, because we doesn't have the value at the moment, because we should create peripherals objects array, and then you're able to pick peripherals object values. For example, you're able to create like same leaves inside your vector and use like leaf here. But at the moment I show that when you have the string array, for example. And here you enter your value, price. Yeah. And you just adding that component, component to your peripherals list. And when you finish, you show your, for example, peripherals dot get show details. Sorry, peripherals show details here, and peripherals get price. It's total price for your peripherals, for example. We're leaving like this the same. After each sorry. After each component we adding to create from scratch the peripherals, we displaying peripherals details and price. Here, of course, you need to create your infinity loop also, maybe, because you're able to attach more than one peripherals. And basically here you need to create also infinity loop, which is able to display and add as many times as you want. Basically create the same stuff as here. While input, or just create some function which is universal for that case. And basically we have create computer from scratch. Pick Razer Naga or Logitech first. And you see the output like peripherals like Logitech 22 and total price at 22. And you're able to create computer from scratch again. We're creating again. Of course, you're able to suggest to add more peripherals and etc. Like adding Razer now. No, not Razer. White 0. Choice is 0. Yeah, shows the same. 22. Oh yeah, it's same price, sorry. Yeah, but we got the different object. We got the Razer Naga, and for the first we picking the Logitech. Yeah. And of course you need to think that how to make this work like this. I don't know. Your way how you implement this functionality here, because I can't to say at the moment how to implement your algorithm here. Because here I suggest to use leaf instead of string, like create leaves. And when you're creating leaf, you should create, I don't know, is it possible to create like this? In C++, I need to check it. Like this. Let me try. Oh, new leaf. Maybe it works. Yeah. Yes, it works. New leaf and new leaf. We have two items, for example, already added as our shop. Doesn't matter. And when you calling object, you need to call some object property. And get price, maybe it returns price. And here, instead of creating new object, because we already created object, we just adding some component which is perf dot choice component. Not viable conversion from leaf. Oh, sorry. Yeah, we need the leaf pointer here. And you have the list of some components added. You're able to create some different leaves. Razer Naga, for example, we creating here. Yeah, we creating like this, and here you need to show arrow because we're using the pointer. And now we adding object instead of creating new object because we already created objects inside this peripherals place. And now when you're running program, you create from scratch. Oh, it shows really strange stuff. Because we printing get price. Yeah. And for that reason, we need to show details. Maybe is it possible to call perf dot perf I dot show details. Yeah, we showing some details for peripherals, and after this we displaying the price and ID. Of course, for a nicer output, you should 221 different price. Should fix that problem to display output in fancy way. Yeah, we have that big peripherals, Seagate hybrids, and of course maybe we need to print it some index also. We have 0 index and second index. If we pick in the first 0, it says that Seagate hybrid price 145.25, total price the same. If you picking the again first, you getting the second price, but as you see, it's not storing the result to our case because you should after you creating scratch, you creating each time your peripherals. That means you're creating new peripherals objects. For that reason, you're not getting updated list, but you're getting or each time created new one. If you're making this outside, yeah, it's not static. I don't know. Is it? You see the change of this without the static. Create computer 0, create computer 1, and as you see here, we got our peripherals global variable, which is stores or saves your objects during the runtime of your program. After you finish, your all create from scratch will be destroyed stuff. Yeah, if you need to make that store somewhere, say that make a static time not using, here you're able to use as a global variable. But if you need it to create some from scratch computer and save somewhere, you should return some object also, and should use inside this loop, or doesn't matter, and pick multiple peripherals instead of single each time, because now you're picking one. After this you need to create from scratch, and again basically you need to create a loop inside this function here. Yeah, that's it. Do you have any more questions?